At the Sudan laboratory, the Fermilab team has gone underground, braving thousands of bats to try and capture a WIMP particle.
This is called the Cryogenic Dark Matter Search. CDMS is the acronym for it. This was an iron ore mine until 1962 when it shut down. We're half a mile underground.
Fermilab has designed a machine that at sub-zero temperatures can detect a dark matter particle passing through it. And its sensor is made of germanium, a dense metal jam-packed with atoms.
It's a very pure block of germanium. It's got on the surface of it a pattern of tiny little thermometers, basically, that are able to detect when a particle passes through this hockey puck-sized chunk of germanium. Dark matter is streaming right through us right now without doing anything. Very occasionally, it will bump into the nucleus of an atom, and that's the signature that we're hoping to see.
To get a clean dark matter hit, Fermilab needed to filter out junk from space.
We would get so many particles that it would be really trying to sift a needle in a haystack.
Fermilab's experiment picks up all matter that passes through this detector. The less junk in the air, the easier it will be to detect a dark matter particle. Because dark matter doesn't interact easily with regular protons and electrons, Fermilab has frozen the germanium pucks to near sub-zero temperatures.
If a dark matter particle comes through and hits a nucleus, it will actually change the temperature of the crystal very slightly. And so we're looking for that tiny change of temperature in the crystal to signal that a dark matter particle has passed by.
16 germanium pucks sit in a chamber inside a clean room.
So we're suited up, we're about to go into the experimental room. It's a class 10,000 clean room. That's why we're all suited up, so we don't carry in any dust, because that would cause a background for the experiment. So let's go inside. So we have scintillation counters that are catching any cosmic ray particles that get all the way down underground here. So right here is what keeps our experiment cold, that tiny little bit above absolute zero. This is a dilution refrigerator. So way inside here are the germanium and silicon detectors. So we're just waiting for a WIMP, a dark matter particle, to get down to this depth and hit one of those germanium and silicon crystals that's buried way inside all this shield.
Fermilab has been visiting the mine for nearly 2 years, trying to capture dark matter. This is far harder than it sounds. Although billions of particles are passing through Earth at one time, it's a 1 in a million shot dark matter will interact with ordinary matter. Getting a dark matter particle to hit a germanium atom is like an archer trying to hit a bullseye when the target is a mile away.
All of these green lights indicate particles passing through the germanium and silicon detectors that we saw downstairs. These are almost certainly all background particles, but maybe it's buried in there someplace as a WIMP. But we won't know until we analyze the data.
Hunting dark matter is tedious. Each day, the Fermilab team reports to the underground lab, analyzes data, and perfects their ping-pong game while waiting for the one hit that will prove dark matter exists. But for all this effort and waiting around, no dark matter has been detected by Fermilab or by anyone else.